Today I'm going to talk about stable matchings. That's the agenda. I will introduce some basic notions about stable matchings, namely the Gale-Shapley algorithm, and talk about two important applications which were mentioned in the Nobel Prize, kidney exchange and student placement problems. Then we will look at the stable matchings from a more graph theoretical aspect. I will introduce what we call a minimum maximal matching problem and tell about its links with the stable matchings. And then I will present the approach of graph classes in order to solve hard problems in graphs. Okay, so let's start with our two Nobel Prize laureates, Alvin, Roth and Lloyd Chapli. So the Nobel Prize in Economic Sciences 2012 was awarded jointly to Alvin Roth and Lloyd Chapli for the theory of stable allocations and the practice of market design. So what is the market design? What is the stable allocations? Well, as you know, economists study how various resources are allocated. And they usually use a price system to make such allocations. Like high wages attract more qualified workers to a particular occupation, or high energy prices induce consumers to save energy, etc. But in some contexts, it's not ethical and sometimes not even legal to use some price system to allocate various resources. Like what? Well, that's exactly the situation for the two applications that I mentioned. When you want to place students to public schools, you cannot use a price system. Or when it's about kidney transplants, right? In these situations, we need to find some mechanisms to decide who will be allocated, what resource will be allocated to what item. And this is the topic of what we call the market design. So, more technically, a stable matching is about the following. Say you have candidates 1 to 4 and institutions, and each set has a complete preference list over the other set. So this reads as follows. Candidate 1 prefers S to O, O to D, D to P, etc. Now, we can